Okay, welcome. This is a short segment on introducing data science and big data analytics for big data transformation. This is a primer for a better understanding of big data and big data analytics and some of the benefits that it can provide to the organization. This is a quote by Anthony Goldbloom. He's the CEO of Kaggle. Kaggle is a company that holds data science analytics contests on the web. It's like a crowdsourced contest for data science. Their motto is they make data science a sport. So they partner with companies, the companies contribute money and data and basically post it to this website that they oversee and they kind of referee and arbitrate so that any data scientist in the world who wants to try to solve these problems can take a shot at trying them, earning money, and also helping companies solve very, very difficult problems. So, for him, the other thing he does is he partners with companies to find out what kinds of problems do they have. So this is a quote he had on Forbes recently, and he said, if he goes into a company and says, what data problems can we solve, executives give him blank looks, right? But instead, if he says, what things can help a company lose money and make money, usually 2 out of 3 are problems data can solve. And I think if you begin looking at problems, you begin looking at scenarios and asking the question, how do we test this idea? How do we prove this idea? How would we disprove this idea from a quantitative perspective? You'll find most problems, these are not new problems, right? Most of them, maybe there's some nuances to make them a little bit newer twist on them. But generally, making money and losing money, selling, finding customers, retaining customers, these are old problems, right? But we're able to take some new spins on ways to do this a lot better. So first, I want to give some applications of big data analytics. And I'm going to start with 3 examples. So I'm going to do one from healthcare, one from telecommunications, and one from financial services. So we'll start with healthcare. With healthcare, there's a lot of improvement being driven in healthcare. Healthcare is a very complex problem. And in the one-day session we do that's really for people who want to head up teams, we have case studies around healthcare and healthcare analytics, and we have a lot of discussion on this. In this scenario, we're going to talk about ways that are traditional approaches to distributing vaccines, right? So in a lot of countries, vaccine distribution is usually based on localized population density and kind of first come, first serve. So if you take a very populated area like China, let's say, they may go to the big cities there and say, we're going to go to these regions and these cities, and we're going to give out vaccines for H1N1 virus or avian flu virus or whatever that happens to be. And, the first people there are the ones who get the vaccines. So to do this, they have to wait for reports from hospitals or agencies or government think tanks to tell them where is there, likely incidence of disease outbreaks and flu, so they know where to send some of the vaccines. But the problem with that is it can take time to do that analysis in a formal way and share the reports, right? That may take 3 to 6 months. And 3 to 6 months when you have a pandemic or you have a rapidly growing virus is a long time, right? And during that time, the pandemic can become out of control. So this is a problem. So I'll show you an approach that we came up with and tried, which is that health agencies can really use social networks now, like Twitter, to look at pandemics in real time or near real time. I mean, for me, it's been around big data for a few years. I've really changed my perspective on things like Twitter. I used to think this was, 99% noise. Now I think it's maybe 95% noise. It's still a pretty noisy medium, but there's also a lot of useful information there if you know how to filter it and how to look for those signals. So, the simplest thing to do is search for tweets. Right? You can really do very large-scale searches on keywords like flu or other kinds of things. We have swine flu, we have regular flu, and it also tells you the geospatial locations of people tweeting in real time about these topics or about these symptoms, and it tells you when it happened. Right? So it tells you the chronology of this. It tells you the locations of the people. Then you can do things like look at the infection patterns. This is somewhat similar to what you were saying before. Right? Except instead of looking at the past, you can look at what's happening now. So I can look at these people and I can create social graphs to understand, who is actually the one who may be the host who's sharing this infection pattern, right? Who is this red dot in the center who's propagating it to all these other nodes. Maybe they have, face-to-face interaction with the people who follow them on Twitter. Maybe they're in the same locations or they work together, right? So you can understand who's following and look at those patterns and look at those relationships. And the other thing you can do is you can geocode those tweets and you can look at the locations worldwide and map them. So instead of looking at, in the last pandemic outbreak 2 years ago, what did it look like? You can look at near real-time information about, where is it the densest, for flu outbreaks? Where are people talking about it? Where are people saying they're getting symptoms of flu virus? Where are people saying they're feeling sick? Where are people saying they want to look for medicine about this kind of a thing? So you get to know, up to the second, up to the minute kind of information. So instead of waiting 3 to 6 months, you can do this in an afternoon. And when it's set up, you can do it very, very rapidly. The second one we're going to look at is telecommunications. And telecommunications, that's a big thing. And I would say telcos have been fairly early adopters of big data because they have so much detailed information. So the situation for this is that we had a mobile telecommunication company wanted to understand why it's losing customers. They realized that there were a lot of customers they had that were just dropping them, and they couldn't really figure out why that was happening. So for them, they wanted to proactively detect which customers were the highest risk for canceling their contracts, right? Or churn, right? Which ones were churning every 3 months, every 6 months, every 1 month, and figure out how they can predict these so that they can retain customers and protect and keep that revenue. So traditional approach is something for churn analysis is to look at spending patterns, right? You could review recurrent problems, and by that I mean, figure out who's calling in to complain, who's saying, I don't like your service, or saying, we think you're too expensive. But more often than not, I think that the customers who are really unhappy don't even bother calling, right? They've stopped wasting their time calling. They think that, calling doesn't do any good to improve the service. So that is certainly one indicator, but in many times, phone calls are not really going to tell you a very good leading indicators of this. The one that we were looking at, that we came up with, which is a real life example that we've done, is to look at the calling patterns and treat the calling history as a social network and as a social graph. So just like we looked at the hub and spoke of the flu epidemics and the network of relationships related to that, you can do the same thing here, right? So here what we're doing is we're looking at, who is this orange dot calling, right? It's calling the gray and the yellow. Who else is connected to it as a network, right, of callers? Because, not just does the telco have the spending habits and how many minutes, but they have the detail. They have the detail of, who's calling each other, how often are they calling each other, who's on your favorites list, who are the top 10 people you call, who are those relationships? And just like you were saying, if you're unhappy with their service, it's likely that you're going to complain to those people or say, oh, this service is horrible, from vendor A. You've got vendor B. Do you like vendor B a lot better? Should I consider going to vendor B, right? So this is actually a really interesting way to do it. And this was kind of a stepwise analysis. The first time it was done by more traditional methods. It was actually done using regression analysis to predict likelihood of churn and look at what are the variables to predict churn. Are they things like spending patterns? Are they low call volumes? Are they low usage patterns? What are those? Are they calling in and complaining with our support a lot? What are those things that would indicate someone's unhappy? And then after that, they said, we can do this, and this will make it a much richer analysis and make it a better predictive analysis. So, if we look at it like a calling graph, a network graph, and we say instead of a flu outbreak, it's a cancellation outbreak, right? How does this spread among a network? The other night I went to a talk by a professor in Northeastern who wrote the books Linked, and he wrote the book Bursts. His name is Albert Laszlo Barabasi. He's one of the world's experts in network science, which is being called network science and complex networks, and basically looking at lots and lots of phenomenon as networks, right? So that means you can look at cell phones as networks. You can look at flu outbreaks. You can look at cellular mutations and disease outbreaks in your body as networks. You can look at telecommunication and cell phone infrastructure as networks, right? You can look at terrorist cells as networks of social relationships. And you can look at these things to understand what are the influential nodes in those networks and predict what are the key points that you have to alter if you're going to affect the outcomes of those. So if we look at this, we say in month 1, we haven't lost customers, but the second month we lose 2. And it just so happens that these 2 are hubs within the network, right? If you look how many links they have to the other nodes, this person has a lot of links, right? So this would be very different if this person left, they're only connected to one other person. But these 2 people are more central to this network. So having them leave is much more important and much more disruptive, right? So we see in the 3rd month, 2 more people who are hubs leave. In the 4th month, 2 more people, 3 more people. So the question is, if you'd known the first 2 customers calling networks, could you have prevented 5 more from leaving, right? And when we did this, it went from something that was done once a year as an analysis to something that could be automated in a large-scale database in under an hour. And it saved a projected $40 million in lost customer revenue in the first year. So this could be automated. Every day, actually, this was run on billions of telecommunication records and cell phone records to look at these kinds of calling graphs and understand, who are these nodes who are most likely to leave, most likely to churn, and then create some things you could do proactively to reach out to them and try to prevent them from leaving. This was actually a really effective thing to augment very traditional kinds of analysis for customer churn. So the third example we're going to look at is financial services. So financial services, the way that loans are processed, this is a pretty old process. It's been around 40 plus years. I mean, it's been around a lot longer than that. But I think about, say, the United States for the mortgage banking industry. If people want to take out home loans, there's some pretty traditional things that are done, right? They're going to verify your income. They're going to look at your employment history. They're going to look at your credit score. They're going to send someone out to appraise the property you're thinking about buying and make sure that it has value or it's not losing value rapidly. So, this is a very traditional way to go about doing it. So I'm going to show you the ones that we had for this example. And I think people hit on almost all of these, right? So we talked about home price trending, sites like Zillow, and there's others like this, but Zillow is a great site for this. Zillow actually also has APIs where you can interface and read their home price data and their neighborhood data and the trending for those areas. One we didn't really talk about as much, talked around it a little bit, was census data. Census data, every country has some kind of census. In the U.S., we do tremendous work on U.S. Census and cataloging and sharing that data. And it's free for anybody who wants to use it. So that data will tell you everything about employment history, education levels in a certain state, county, city block, county, whatever you want to look at. It will tell you demographic changes. It will tell you, what kind of loans people have tried in those neighborhoods in the past. Who is paying for high-cost loans in that neighborhood. How the population and the demographics of a neighborhood are shifting. Tell you all kinds of things like that. We talked about localized job and market trends. We talked about geographic hazard risks, right? Historical loan data, we heard that one. And we heard professional and social history of the applicant. That was the LinkedIn and Twitter. When we looked at this, the other thing people were doing for the social data, they're really taking social data very far. Very far. Just like, I was kind of joking about Twitter, where I thought that was mostly noise, but there's a lot of really excellent research people post, and they post links on Twitter to the research. But likewise, even on Facebook and LinkedIn, and you have a lot of large organizations figuring out how can they make use of that data, right? So in this, I was reading about people who are building companies to actually use the data on the blue side of this picture and very, very rapidly qualify or pre-qualify applicants to do this. So people are actually doing this. I read about companies in the UK who are doing this and who are building it and who are funding it. The other thing is I see people trying to quantify things that are difficult to quantify, right? So they're doing things like saying, if I look up an applicant and I track that applicant through a loan process, what's the financial impact if they change their status from married to single halfway through the loan process? How much does that cost them? How much risk does that introduce? How much volatility does that introduce? So, even just what seem like small changes people are interpreting and trying to measure, what is the impact of doing those things. So for this, we're saying you could do this a lot quickly. Even if you took off a week or 2 weeks, you could probably cut it by a third. I think this is even pretty conservative. You could cut this by quite a lot more. The thing, though, is, that may shrink this middle part, the pre-approval and the underwriting. I think that's where you would really shrink it. But, of course, you still have to do closing. You have to get attorneys and sign papers. You have to do a lot of that work. Although there's even companies now that do all that on the web. And they get online attorneys. They do online digital secure signatures. Even that part is being compressed and finding ways to automate that piece also. Excellent. So that concludes the first section of today's module.